Okay, so for this last section, we're going to be talking about powers of 10. So throughout this lesson, we're going to be going over like multiplying by powers of 10, so like 10, 100, 1,000, dividing by 10, dividing by 100. So a lot of that is just moving the decimal place. So some of these, like multiplying by 10 or any power of 10, you can almost do mentally. You just have to know how to move the decimal place. And we will talk a little bit about exponent rules, which you saw some of that in Algebra 2. You also might have seen it in Algebra 1, because I know I talk about it in Algebra 1 with my students. So when you're multiplying and you're dividing by powers of 10, if the exponent is positive, you shift the decimal to the right, and then you attach zeros if necessary. So wherever the decimal is, and if it's a whole number, remember that the decimal is after the last number, because it's like point and then a bunch of zeros. So if I'm multiplying it by like 10, 100, 1,000, 10,000, any of those numbers, I take my decimal and I move it to the right, depending on how many zeros the number has. So like 10, you would move it one time, because 10 has one zero. 100, you would move it two times, because 100 has two zeros. And then you just fill in any empty spaces that you have with a zero. If you're going the other way, so like when you're dividing, then you move the decimal to the left instead. So for like 275 times 10, if you were doing it mentally, which you don't have to do these mentally, you could just type it in your calculator. Your decimal is sitting right here, and we're going to move it one to the right, so we have to fill in this blank with a zero. So you get 2,750. So what would be 0.18 times 100? 18. How about 2.4 times 1,000? Last one. So that last one actually is moving the decimal to the left, because 0.1 would be the same thing as like 1/10. So it's really dividing by 10 there. Okay, so then we also have dividing by a power of 10. So if you need to, you can change the division to an equivalent multiplication problem, but you don't have to. Like if you know, use a calculator to help you if you need to like divide the numbers, but you can also just move your decimal mentally. So if I'm doing 3.14 divided by 10, I take my decimal and I move it one to the left. So this would become 0.314. I usually put 0.314. You don't have to have that zero in front of it though. How about number 2? What would you do to be? Good. 0.0048. And how about the number 3, the last one there? Move it 3 times to the left. Okay, now we're going to get into some exponent rules. So all of these up here at the very top of your guys' page talk about the rules that you have to follow when you're dealing with exponents. When you are multiplying items that have exponents, and so in a lot of times you're only going to see like bases of 10. They don't really go into other bases, but the numbers that you're multiplying have to have the same base, which means that it has to be the same number. The exponents could be different though. So it could be like what you're going to see, which would be something like 10 to the third times 10 squared. But it also works for 5 squared times 5 to the third, 2 squared times 2 to the third. These same rules would apply. If you're multiplying, the big rule is right here. You have to add your exponents. So if it's 10 squared and 10 to the fourth, you add the exponents 2 and 4, and you get 10 to the 6th power. Now for most of these, I don't mind if you just leave it in exponential form. So if you just keep it as 10 to the 6th power. If you want to evaluate that, you can. There is a possibility that you might get something like 10 to the 12th power, and if you do that on your calculator, it'll give it to you in scientific notation, because it doesn't have the space for all the zeros, potentially. So it's okay if you leave it in exponential form. So for multiplication, you add exponents. For division, you have to subtract exponents. And kind of a caveat to this rule is that if you happen upon a negative exponent, so if you subtract your numbers and it becomes negative, you can't leave it negative. You have to make it become positive. And so in order to do that, it drops to the bottom of the fraction and you put a 1 on top. So if I had 10 to the negative 2, let's say, I would drop that underneath here so it becomes 10 squared, positive 2, and then there's a 1 on top now. So if I'm multiplying like 10 to the 5th times 10 squared, I don't do anything to my 10, but I add my exponents. I add my 5 and my 2. And so my answer would be 10 to the 7th power. And again, I'm just going to leave it right here. I'm not going to worry about evaluating that. You can if you want to, but like I said, you might get some answers that your calculator can't process how many zeros it has. There's just not enough room for it to show you. Number 2, what happens if you add negative 1 plus 2? It equals 1. So 10 to the 1st power is the same thing as 10. So if you have a 1, you can go ahead and just drop the exponent. It doesn't change anything about the number. What do you think number 3 is going to say? 10 to the 3rd, because you're taking 0 plus 3. So you have 10 to the 3rd power. What do we do with exponents of number 4? Subtract. So what exponent does the top one technically have? A 1. Okay, so again, if a number is sitting by itself and there's no written exponent, that's because there's actually a 1 there. We normally don't write the 1s, because if you did, every single number that you ever saw in a worksheet, a textbook, or anything would have little tiny 1s, and it would be super messy and just unnecessary. So we don't write them. But when you're doing an operation with it, you might need to know that that's there. So for division, we have to subtract. So we take 1 minus 3. What's 1 minus 3? Negative 2. So what do I need to do to finish this one? Drop it to the bottom of the fraction, so it says 10 squared, and a 1 has to be on top. Like 10 to the 3rd over 10 to the 1? Yes. So if it said like this instead, then you would do 3 minus 1 and you'd get 10 squared. So you wouldn't have to write that one as a fraction because the exponent stayed positive. Oh, so like if it was already a fraction and it had a negative exponent? So if it looks like this, like let's say it's 1 over 10 to the negative 4, like that. If that's your final answer, you have to take this then and drop it up, like bring it up to the top so that it becomes positive. So then it becomes 10 to the 4th. And that would technically be over 1, but you don't need to write over 1. And that does happen sometimes too, that you actually have a negative in the fraction and then you have to move it. All right, the last rule is if you're doing a power to a power. So this is a little bit different than just multiplying bases because you've got something with an exponent and then all of that is in parentheses and there's another exponent. When this one happens, you have to multiply the exponents. So you have to take the two numbers and multiply them instead of adding them like we did previously because it's written a little bit different. So for the first one, you have 10 to the 3rd and then all of that squared. So essentially what you're doing is you're taking 10 to the 3rd times 10 to the 3rd. And so if I added those exponents, I would get 3 plus 3, which is a 6. So it's the same thing as on this problem taking 3 times the 2. I get 10 to the 6th power. So for number 2, what would be negative 3 times 4? Negative 12 And so what do I need to do to finish this one? Yep, 1 over 10 to the 12th. And again, you don't have to worry about evaluating that because it's going to be a really small number. It's going to be 1 over 10 with a whole bunch of zeros after it. So if you actually divide that, it's going to be a tiny decimal. And your calculator is going to give it to you in scientific notation because it's too small for it to display all of it for you. So you can leave it right there.